Question 26. Use the slope-intercept form to graph the equation y equals negative 5 over 9x minus 5. Well, again, we're being asked to graph this equation, and they come right out and tell us to use the slope-intercept form to graph. But even if they didn't come out and say use slope-intercept form, notice that again, we don't have an XY table of values here to find and plot. So this is your indicator that this equation must not have a whole bunch of work to it in order to graph. But because they are specifically telling us to use slope-intercept form, recall what slope-intercept form is. And that, of course, is y equals mx plus b. And the reason we like graphing equations in this form is because we can identify two key pieces of information immediately without any work. We can identify what the slope is, right? So this is the rise over run. And we can quickly identify what the y-intercept is based on b. This is the y-intercept. Where does your graph cross the y-axis? Now, we plotted, I think, a few questions back. I don't remember how many back. But we plotted equations that were in slope-intercept form. And we talked about the first thing you always do when graphing in slope-intercept form is to plot your y-intercept. So if we're looking at the given equation, y equals negative 5 over 9x minus 5, we can identify that our slope for this particular line is negative 5 over 9, which means we're going to fall 5 units and run 9 units. So negative 5 over 9, and our y-intercept comes from right here. And remember, the y-intercept is a point. It's an ordered pair. So in this case, it will be 0, comma, negative 5. And for y-intercepts, the x is always 0. So let's go ahead and just graph this by hand real quick, just so we can get an idea of what this line looks like, and then we'll use the graphing software to actually enter our final answer. So we have to start by plotting the y-intercept. So we always begin at the origin. This 0 in the x coordinate says don't move left or right any, but you are going to drop to negative 5. So we're going to drop to negative 5, and there we have it. And then from the y-intercept, you are going to use the slope to get to the next point. So remember, this is rise over run, but in this case, because the rise is negative, we're actually going to be falling 5 units. So let's drop 5 units. 1, 2, 3, 4, 5, and then we're going to run to the right 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So right there. And then all we have to do, if we were graphing this by hand, would be to use a straight edge to connect those 2 points. And there we have our line. But of course, we need to graph this using the software. So let's go ahead and do that. And I'll clear the screen here, and we'll pull up the actual software. So again, based on this equation, we know our y-intercept is negative 5, so we're going to select the line tool and plot negative 5 on the y-axis. So again, look in the upper right-hand corner of the yellow box. Make sure that ordered pair that's shown there in that yellow box is what you want to plot. And in this case, it is. So 0, negative 5. We left-click with our mouse. That locks in that first point. And then from that y-intercept, we're going to drop 5 units and run to the right 9 units. So drop 5 units, 1, 2, 3, 4, 5, and run 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, click. That locks in that second point and therefore locks in our line. We're going to save, and now you can see that our line is locked in for our answer, and there we have it. We've just graphed y equals negative 5 over 9x minus 5 using the slope-intercept form.